Good afternoon. Can everyone hear me just fine? All right, seems like, all right, well, let's get started. My name is Brian Matthew. I'm a program manager in the storage and file systems team in Windows Core. Just set a little background. Our team delivers the storage platform, delivers storage spaces, delivers file systems, delivers a storage stack, storage drivers, scaling up from Windows RT, where we developed the SD boot driver, to your laptops, to your phones that's also running Windows file systems, Windows storage stack, and scaling all the way to the large data center. So when our team designs features, we really need to think about how this scales from small, how this scales to large. And we build features that deliver all this. Just to set a little background to what our team is. So the agenda for this talk is, well, let's first walk through some different approaches that we can look at deploying storage, different kinds of disks. What do these disks deliver me? And how can I choose? What is the criteria for me choosing this? I'm going to give a brief introduction to storage spaces. We're going to then show you how you can best deploy storage with spaces that gives you the best balance between dollars per terabyte and IOPS per dollar. And then we're going to actually deploy it using PowerShell. So we have a little boring PowerShell demo at the end that I'm sure many of you will enjoy. But first, a little background. With R2 and with 2012, one of our big focuses has been to dramatically, and when I mean dramatically, I really mean dramatically, reduce the cost and complexity of deploying and managing storage for our most cost-conscious customers. Those that deploy infrastructure as a service storage platforms, namely hosters. We think of hosters as large companies that deploy big platforms for data, but it's really most companies nowadays are deploying some infrastructure as a service. Whether they know it or not, they are deploying infrastructure as a service. They have a large service they need to deploy for their users, and they need to have the infrastructure for that. Be it dedicated VDI, be it hosted cloud, private cloud. Most companies need to deploy this in one shape or form. And of course, they need to deploy it while reducing the costs, reducing the complexity needed for that. Now, to dramatically lower the cost and complexity, we've done it in two ways. Number one, to disaggregate compute and storage. When I want to invest in compute, I invest in compute. As my users or as my workloads need more compute, I add more Hyper-V nodes. As my storage needs increase, I add more disks. I add more storage file servers. I can independently scale these two metrics. And the other way we're achieving this dramatic cost reduction is by utilizing industry standard commodity components wherever possible. I have commodity storage, disks, JBODs. I have commodity networking, simple switches, commodity servers, and commodity interconnects to throw all this together. Now, the components that comprise this stack, starting from the actual storage, is I have shared JBODs. And these JBODs have disks. They're just disks. They're raw disks. Very simple JBOD unit. Really has not a lot of intelligence in it. So you can imagine that they're cheap. These JBODs are then connected to my Windows file server nodes, commodity servers. They're connected through SAS. The storage and the servers connected through SAS. And the servers are connected through Ethernet, my high-speed 10 gig or InfiniBand or what have you. The components that manage the cluster, I have Windows clustering. I have scale-out file server. And from this file server, from these clustered file server nodes, I provide data access to my virtualized workloads managed by Hyper-V. So I have a cluster of Hyper-V connected through SMB to my Windows file server, which is in turn connected to my JBODs with my storage managed by Spaces. And this end-to-end stack, from your storage to your file servers, to your shares, to your Hyper-V cluster, is managed by PowerShell and SCVMM. So I have cost reduction. I use commodity components. And I have easy management, PowerShell SCVMM, end-to-end. Now, this way of deploying your storage is really no different architecturally than how you traditionally deploy storage today with a fiber channel or iSCSI storage array. Starting at the component level, we can make a little comparison here. So my storage array has fiber channel or SAS disk shelves. Storage spaces uses shared SAS JBODs. What are these both things? They're exactly the same things. They're a chassis to store my disks, and it has a backplane, and it has controllers. Traditional storage array has some amount of storage compute. You're going to find CPUs in there. You're going to find processors. Those are running proprietary hardware, proprietary software. With the Windows file server cluster, I have commodity servers running Windows. So these servers are easy to manage, and you manage them just like any other server you manage them today. As my data needs increase, I can even upgrade these servers. Put faster processor, put more RAM in them, put more NICs, put more HBAs. Very easy to scale these servers in terms of capabilities. The biggest difference between these two approaches is the protocol used to communicate from the storage to my workload. With the traditional storage array, I'm talking block over fiber channel or iSCSI. I unmask a LUN from my storage array, and I present that to my Hyper-V compute node, where I present that to a number of my Hyper-V compute nodes and have clustering in there. In my Windows file server cluster, I'm talking file. So it's going over SMB. I have all the capabilities of SMB3, RDMA, SMB multi-channel. And I present shares to my Hyper-V compute nodes. So file versus block. But in the end, from my Hyper-V compute node, it's where my workload's running. Really, what is your workload running on? It's running on files, be it on a volume or be it on a share. From the workload point of view, it's the exact same thing. Architecturally, at the component level, it's the exact same thing. Storage compute, disk shelves, or JBODs. Now consider for a moment a couple approaches that you might use to choose what kind of storage you'd want to deploy. So most basically, there's two approaches. You can have a capacity optimized approach or a performance optimized approach. And well, ideally, you'd want something in between the two. But let's first focus on the capacity optimized approach. We want customers that want the most capacity, most bang for their buck. They want the highest, or they want the lowest, dollars per terabyte, the most cost-efficient storage possible. And just a case study here, we have an internal engineering team called the Windows Release Team. And this team manages Windows build symbol data across all the Windows build repositories, across all the teams, across Windows. That's a lot of data they have to manage. And because it was a lot of data, they had a lot of complexity with their existing infrastructure. And I'd go a little more in depth in my talk tomorrow on this, but just a couple highlights. They had problems they needed to solve. They had real-world problems with their data. They didn't have enough capacity, it cost too much, and they had too many servers. So we worked with them to deploy Spaces. This is what they saw. They doubled their storage throughput with Spaces. They tripled their raw capacity with the same budget they had to replace a third of their deployment. They were able to instead replace their entire deployment. With data duplication and this tripling of the raw capacity, they saw a 5x increase in the effective capacity of their storage. And because Spaces allowed them to deploy with much higher density, they reduced the number of servers they had to manage by 6x. They culled 8 full racks full of gear. So you look down at data center, you have 8 racks now missing. You have 8 racks, you have 8 racks less of electrical, you have 8 racks less of cooling. This is what's possible with Spaces. This is what they did with Spaces. Jeremy Russell from the team has a quote here, and I'm just going to paraphrase him, but he was able to achieve the same functionality of a traditional storage using commodity hardware and using Spaces. Now, another case study, just a brief look at this case study, is that Microsoft ships a question? the gentleman is asking, are these case studies about 2012 or 2012 R2? And these case studies are on the platform we shipped in 2012. So just a year ago, we have customers, just a year ago, we shipped 2012. We have customers already using Spaces to solve real-world problems, already using Spaces and already getting a number of benefits from using Spaces. So yeah, these are on 2012, and it just gets better with R2, which I'll talk about in this talk. So Microsoft ships a parallel data warehousing SQL appliance. And they had a number of issues with their previous architecture, and they looked at Spaces as a way of improving their performance, and they looked at Spaces as a way of reducing the cost. By using Spaces, they immediately halve their hardware acquisition costs. The cost for them to go purchase hardware to ship to a customer, they cut it in half by using Spaces. They doubled their storage throughput. They got better performance. They tripled their data density. They're using JBODs that have much higher density disks. You can stick more disks into less use of space. And most importantly to them, actually, because a lot of customers use the complex query execution time as a metric for comparing two different PDW appliances, they got a 5x reduction in the time to execute these complex queries. So they saw a lot more business because Spaces were able to deliver them so much more performance for less cost. And Paul Dyke over at PDW basically is saying the same thing as Jeremy Russell. It's a key foundation of their appliance. Vastly improved their price-performance ratio and really was a game changer for them compared to many other solutions that were on the market, and enabled them to compete better. We have another approach, performance-optimized approach. And we have many workloads today that demand the highest of performance. And Spaces can absolutely scale to these levels of performance. Last year at TechEd, we showed a configuration where we had 3 high-performance clustered file server nodes. And they were connected to a 24-bay 2U JBOD full of SSDs. So we have 24 SSDs. We have 3 high-performance server nodes. We were able to push 1.45 million IOPS out of this 8U configuration. And sequential performance gave us 12 gigabytes a second of throughput. So you can imagine that's an immense amount of data you can push through this JBOD, push through this commodity hardware connected to commodity servers, commodity interconnects, using the Windows stack. And you can scale this out even further by adding more JBODs. So given I have a performance-optimized approach, I have a capacity-optimized approach, how do I build a deployment with these goals in mind? I want 16 terabytes of capacity, but I also have a workload that will demand 180,000 IOs per second, simply by the nature of this workload. How do I do this? I could try it with hard drives. I meet my capacity very easily with huge drives that are available today, but I'd miss my IOPS goal by a large margin because simply these drives are not optimized for IOs per second. They're not optimized for seeks. Now, I could try the same thing with SSDs. I'd meet my IOPS goal very easily because SSDs are screaming fast. But I'd miss my capacity because I wouldn't be able to deploy the number of SSDs needed to meet that capacity given my reasonable budget. So again, we need a more balanced approach between these two. And by using those 6 hard drives, by using those 4 SSDs, putting that into a single intelligently managed thing, I can meet my goals. I can meet my deployment goals of 16 terabytes and 180,000 IOPS. I mean, if I tried to meet my capacity goals and my IOPS goals with SSDs, I'd need 20 of them. It's going to cost me 60 grand. This mix is only going to cost me $14,000, a dramatic reduction in cost. Now, before I go into that, let's give a brief introduction to storage spaces, especially for those in the room that may be unfamiliar with the concept. I mean, we've only shipped a year ago. We only shipped Spaces a year ago. So it's going to take time for people to get this knowledge, get to understand what Spaces really represents. Now, it's funny because we presented the same talk at TechEd North America, and this slide had less hardware. So in just 2 weeks, we were able to add 3 products to this slide, able to add 3 certified Spaces hardware to this slide. There's a lot of trajectory here, a lot of acceleration as to the vendors that are supporting Spaces, as to the products available out there that are Spaces certified. Now, we have a place that you can look at what certified hardware there is currently available in the market. That's the Windows Server catalog, and we actually have a storage Spaces category. So vendors submit their logo certification, vendors run their logo certification against their hardware, and if they pass, we put them up on this website. We promote their hardware as Spaces certified. But anyways, here's a sampling of the certified hardware that's available on the market today. We have stuff from Fujitsu. We have stuff from Rating. We have stuff from Data on Storage. We have stuff from Quanta. We have stuff from Supermicro. Now, all these are inexpensive boxes, and they're very simple. Obviously, they're sheet metal, but they have a SAS backplane to connect my enterprise-grade dual-port SAS drive to. They have redundant power controllers. They have redundant SAS controllers to ensure that this piece of hardware is resilient against power failures, and it's resilient against path failures, resilient against controller failures. So these are enterprise-grade pieces of hardware that you would typically see with your previous Fibre Channel or SAS disk shelf. So starting from 2 24-bay JBODs, I'm going to build up Spaces just to walk through the overview. So I have 24 disks in each, so a total of 48 disks. Now with Spaces, I don't manage physical disks individually. I don't create RAID groups. I don't do any of that stuff. I simply create a storage pool from these physical disks. I manage the storage pool. This is an abstract concept, but I manage that. It's integrated right into Windows. From my storage pool, which manages all these disks, I carve out flexible, resilient storage spaces. Many of you will be familiar with the concept of virtual disks. Not virtual hard disks, but virtual disks as presented by traditional storage arrays. Exact same thing. Storage space, virtual disk, interchangeable terminology. These storage spaces have resiliency. I have mirroring. I have parity. I have dual parity. Two-way, three-way mirroring. I have different options to keep my data protected, to distribute copies of my data across the physical disks in my pool. And Spaces, by distributing the data across the physical disks in the pool, it improves your performance. It significantly improves your performance. When I write or when I read to my storage space, that gets broken up into smaller chunks, and those are then serviced by multiple physical disks simultaneously. Significantly improves the performance. With Spaces certified hardware, such as the hardware you saw on the previous slide, Spaces provides this additional capability. When I create a resilient storage space, in other words, a mirrored or parity space, one that provides multiple copies of my data, Spaces will place that data on separate JBODs to ensure I have resilience against one of those JBODs failing. I still have the data on the other JBOD. I still have another copy, complete copy of my data available on another JBOD. And when this JBOD, this failed JBOD, comes back or I replace it, Spaces will automatically resync the data, automatically make everything resilient again. And this is possible with Spaces certified hardware. Because Spaces certified hardware, what that basically means is that those JBODs are able to identify what disks are in what enclosures. So my disk has an enclosure ID. It tells me what enclosure it's in. My disk understands what slot it's in as well. So when a disk fails, we're able to automatically blink that disk's LED to tell you, hey, replace me. Or tell the storage array to blink its own failure LED to say that this array has a failed disk within it. This is possible with certified hardware. With volumes running NTFS or REFS atop of a resilient space, we have a system service that runs in the background and protects my data against latent corruptions, protects and autocorrects. both for our NTFS and REFS, and it's even better for REFS. And most importantly, my data is continuously available because I have Windows File Server and Windows clustering. And I'll get into that in the next few slides. What if a disk fails with Spaces? Of course, the big question. Spaces needs to protect your data. It needs to be performant in the case of a disk failure. But because we spread the data out amongst multiple disks, that means all your copies of data is going to be on different disks potentially. What that means is that when a disk fails, I can rebuild that data that's logically lost to multiple spindles simultaneously. My data spread out on different disks, I can take that and spread it out onto other disks using the spare capacity that's on my physical disks in the pool. And because we do this, because we use the spare capacity on the physical disks in my pool, my rebuild times are dramatically improved. We have a test here internally that we've done where we have 8 3-terabyte nearline SAS drives. And we create a mirror. We simulated a failure of one of these drives. So I basically had 2.4 terabytes of data to rebuild in my mirror space here. We're able to rebuild this 2.4 terabytes of data in 50 minutes at a throughput of 800 megabytes per second. This is what parallelized rebuild gives me. Because I spread the data around, I can also rebuild it in a parallelized manner. If I had a hot spare, what that means is that that hot spare is then the bottleneck for my rebuild. Because that disk is only going to give me maybe 150 to 200 megabytes a second of sequential writes, if even that. By having parallelized rebuild, using spare pool capacity, I'm able to recover from a failure. I'm able to get my data back into a healthy state much quicker than I possibly can with many other solutions. Let's talk about availability. So I want to build up a little cluster here. I have 4 60-bay JBODs. So these are 4U JBODs that contain 60 disks. Now that's a lot of disks in 4U. So here I have a total of 240 disks. And I connect these to these clustered file server nodes. And I connect it in such a manner that each file server sees the exact same set of disks from all the JBODs. So each file server also sees 240 disks. It sees the state of those disks and is able to recognize what's on them. Okay? I create a storage pool from all 240 disks. And I carve out some resilient virtual disks, resilient storage spaces. But because now I have multiple virtual disks, I have multiple file server nodes, I need an easy way to access my data. I don't want to go to each file server node, do whack whack node 4 and figure out what storage is on there. I want a much easier way that's going to scale. So I add these disks to CSV, clustered shared volumes. Provides a unified namespace for data access across the storage that's in the cluster, regardless of the number of virtual disks I have, regardless of the number of nodes I have. It's one namespace. And as I add more disks, as I add more servers, CSV grows. The CSV namespace grows, but I still have one point of access. Whack whack cluster, volume 1 or share 1, and whatever shares you have set. From CSV, I create a scale-out file server. Each node, with scale-out file server, each node in the cluster is now a file server. What that means is that data access coming down to my cluster is load balanced and distributed throughout the cluster. This significantly improves my performance. From scale-out file server, my storage is shared out to my virtualized workloads, my Hyper-V compute nodes. And this is done through SMB. So I have all the great benefits of SMB3 that I'm sure, yes, sir, question.
If I'm correct, scale-out file server was recommended for databases.
Sorry, can you repeat that?
Scale-out file cluster
Yes.
is recommended for databases.
For SQL? So the gentleman is asking, is a scale-out file server recommended for SQL? I'm not sure of the SQL specific workload recommendation, but I can definitely talk to you about that. We expect most customers to run SQL in a virtualized environment within their Hyper-V compute nodes, and that's absolutely supported and recommended with scale-out file server. Does that answer your question? Most workloads are going to be virtualized. I have Exchange, SharePoint, SQL, VDI, what have you. That's all going to be virtualized, and that's all shared out through scale-out file server. And that's absolutely supported and recommended as a deployment method. We can talk more about that, or I can find out more if you're talking specifically about a physical server case. So I have CSV. I have scale-out file server. I have continuous availability. I have an easy way to access all my data, single namespace. I have spaces providing me resiliency for my data against disk failure. I have spaces also providing me resiliency against JBOD failure with certified hardware. I have high availability. One of those nodes go down, another node takes over. And this is all with Windows. I can scale this out even further, taking those 4 clustered file servers, and taking 4 of those 60-bay JBODs. So basically this bottom part of this previous slide, taking this, I can scale it even more into different units. Now these different units aren't connected at the SAS level. They're not connected at the SAS level. But because they're clustered, I can have these units right next to each other, and they can access each other's data. So from each unit, it has its own storage pool. It has its own set of virtual disks. And across all these different units, I still have my CSV. My CSV provides the integrated namespace across all of these different units of storage. So my scale-out file server can continue to access that point, and I can continue to provide storage out to my virtualized compute nodes. And this scale is done completely linearly. And I can deploy this in a just-in-time manner. And we have a customer today. I just want to highlight this customer, NTTX. They're a hoster in the UK. And I mean, they can't go and buy this complete set all at once. It's not practical. I mean, they only have a certain amount of customers at a certain point in time, and customers come in all the time. They can't go and make this in one-time investment. What they're going to do is they're going to make investments in units. As more users come in, they're able to provision their storage in a just-in-time manner. They're able to add more of these units, maybe not these specific units, but they're able to add more of these units, add more virtual disks, and it simply is still unified in this CSV. So it's very easy to manage. And because of this linear scale, they're able to significantly reduce the cost and complexity of deploying their storage. So let's talk about now how to deploy it with exceptional IOPS per dollar. By the way, if you have any questions, again, feel free to ask before we move on to this slide here. We talked about capacity optimized approach. We talked about the performance. Now let's talk about the one in the middle. If we look at common enterprise workloads, we look at SQL, we look at VDI, look at Exchange, look at IIS. We look at these workloads. A lot of them share many of the same characteristics in terms of my data set, in terms of characteristics of my data set. I have a very large data set, or most customers do. They have a very large data set. But the majority of the data is cold. I mean, you look at the most basic example of a VHD file. When I boot a VHD file, only a certain part of that VHD file is actually accessed during the boot. Only a certain part of that VHD file is actually accessed when a client connects to it. So it's going to be cold. A lot of it is going to be cold. My database, only a portion of my database is really ever active, really active. So a lot of it's cold. But I have a lot of data lying around. A minority of my data is in active use, and it's thus hot. And this portion of the data is called the working set. And of course, this working set changes over time. It's a different working set every day. Different portions of my database get accessed. Perhaps a user loads a different application. That application has a bunch of other dependent files. So your working set definitely changes over time. And it can continue to change. And we also look at the types of drives available today. We have nearline drives, 7,200 RPM drives. They're capacity optimized. By deploying these nearline drives, I drive down the dollars per terabyte to deploy my storage. I have solid-state drives, too. And these are performance optimized. They deliver amazing performance. And by deploying solid-state drives, I drive up my IOPS per dollar. And it's interesting because we look at the hard disk drives and we look at this large data set, it seems to match up because my large data set is very large, it's very cold. So why not use these hard disk drives to deploy my large data set on? And we look at the working set. I have a small working set. SSDs are relatively small. They're high in cost, but deliver amazing performance. It seems to make sense to place my working set on those SSDs. But of course, we need a mechanism to easily and seamlessly manage my hard disk drives and my solid-state drives and handle that changing working set. And that's exactly what we're doing in R2. And we had a lot of customers just demand this feature. And of course, well, I'm sure you can imagine conversations at the end of 2012. We have very tight integration in the file system, both NTFS and REFS. The file system will, in the background, determine what data is hot and what data is cold. It'll watch for I/O activity to your virtual disk. And we do this at the sub-file level. We track your data in 1 megabyte chunks. We track your data in 1 megabyte chunks. Not too big, not too small. And it's interesting, because we are integrated into the file system, we're able to do a few unique things. Number one, when I delete files or when I free portions of files, that will immediately free space from the SSD tier. There's no delay, there's no reanalysis. It immediately frees that space. So I can continue to place files in my SSD tier right away. Another thing, because we integrate closely into the file system, an administrator is able to override this automatic placement based on heat. They're able to say, I want this file placed in the SSD tier. I don't want Windows to tell me where it's going to go based on heat. I want to set this manually. Or conversely, I want to place this file into the HDD tier. You can imagine the most basic scenario for this is a pooled VDI where I have a parent VHD. I tell Windows I want to place this parent VHD file into the SSD tier of my virtual disk. Windows will then place it, and then what happens is that boot times of my VMs just dramatically increase. Or I can do the same for cold data. I can say I want Windows to ensure that this file is always on the HDD tier. This file, regardless of how hot it actually gets, I don't want it to move anywhere. This is possible because we've integrated so closely into the file system. It's a lot closer to the administrator, a lot closer to the data. Tiering is a scheduled task, and it happens every day. So the current default is it happens every day at 1 a.m. You can configure this because it's a scheduled task. You can do this through PowerShell. You can do this to the scheduled task UI. So what happens at 1 a.m. every day is that tiering comes along, analyzes the heat database, analyzes basically where all the files are, what's changed, what's become hotter, what's become colder, and what have you told me to go pin. It's going to go process all this and come up with a list of stuff to move. It's going to then move it. It does this in the background and in a manner that minimally impacts your workload. And in fact, in the demo I'm going to show you, there was no impact to your workload. So tiering is a scheduled and periodic event. So you can change the schedule to meet how your data moves. You can change this, for instance, if you see that you have significant changes in data patterns over a week. You could have tiering come along and say, I'm going to optimize at the end of the week rather than every day. You can change this as your workloads need it. in addition to the performance counters that you have already to determine how well your workload's performing, how well your VMs are performing, we also have an analysis report that we spit out at the end of a tier optimization. This optimization report is able to help you determine how efficient is my SSD tier at handling most of my IOs. Does it handle most of my IOs? What percentage of the IOs does it handle? And what are the benefits of increasing the size of the SSD tier? If I increase it by this much, how much more of my IOs would I be able to put in my SSD tier in the best case? So we can tell you if you have enough SSD tier for your workloads and if you need to increase it. Based if your workloads change, you can increase it. We also have another capability in R2 called the write-back cache, which is a per virtual disk write cache that utilizes SSD capacity in the storage pool to smooth out short-term bursts of small write activity to your virtual disk. We see in our data center, there are a lot of random writes that come up. These random writes can significantly reduce the performance of a lot of workloads. The write-back cache helps absorb these periodic spikes in random writes so that they don't affect my workload as much. And the way we've implemented our write-back cache is that it's a persistent cache. There's no RAM. What that means is that this enables me to fail over or move my storage space between nodes in my cluster, and I still have my write-back cache there. I don't have to flush my cache before I move it between nodes. I don't have the issue of cache synchronization between file server nodes. I don't have all these problems because I simply use the SSDs in the storage pool as a means for my write-back cache. And write-back cache and tiering are complementary. So I can have a tiered space with a write-back cache. Or I don't have to use tiering to have a write-back cache. I can simply have a write-back cache for any simple or mirrored spaces. It's enabled by default. We have intelligent defaults, and we're still working on the default number, but we do have a default. And it's configurable through PowerShell. So when I create a virtual disk, I can specify a write-back cache size. And I'm going to show you the PowerShell at the end of my talk. Let's first give a little demo of tiering and the write-back cache. I'm going to switch over to my other machine here. Okay. So remember when I talked and I said that the write-back cache smooths out periods, short-term bursts of random write activity? I'm going to prove that to you right now. I have two perfmon windows open, and I have workloads running in the background on two volumes. One volume is with a write-back cache, one volume is without. And it's the same workload parameters. It's basically just SQL I/O. Okay? And that's indicated by my blue line. So my blue line on both graphs are giving me about 550 IOs per second. Okay. Superimposed with this blue line is a dotted red line. This dotted red line indicates the total IOs per second being serviced by that volume. So that means my blue line workload and any other workload I introduce to the volume, such as write spikes, for instance. I'm going to now trigger write spikes into both volumes, the same write spikes, and I'm going to see how each volume handles it. The volume without a write-back cache, you can see the workload, my SQL I/O instance running in the background, just had a dip in the number of IOs per second it was able to deliver. However, you can see that both volumes, the dotted red line indicated that more work was done because I introduced the write spike. So I had my blue line SQL I/O workload and I had my write spike workload. So more work was done. But the volume without a write-back cache, my SQL I/O was just impacted by that write spike. The volume with the write-back cache, there was no impact to my SQL I/O instance. Now when I deliver another write spike, you can see again, more work was done by both volumes, indicated by the dotted red line, but my SQL I/O running on the volume without a write-back cache was negatively impacted. Now let's continue to the tiering demo. What I'm going to show you is a seamless transition of a file from the from the HDD tier of a virtual disk to the SSD tier. But the kicker with this demo is that while this file is being moved between tiers, I have an intensive I/O test being run on this file. Very high queue depth, large number of threads, random I/O. Okay? Again, I have a perfmon window. We seem to love perfmon in our demos here. I'm doing I/O to the file. It's currently completely allocated to the HDD tier. So it's giving me roughly 2,600 I/Os per second, which is about what these hard disk drives should give me in this configuration. So you can see it's pretty consistent, 2,600 IOPS. Now I'm going to kick this file on over to the SSD tier. Now I didn't pause the workload. You can see the workload's still running. I'm still doing, a number of IOPS per second. My workload is still running. What's happening in the background, though, is that Windows is moving the blocks underlying the file to the SSD tier. And this is done completely transparent to the running workload. It's done in a completely transparent manner. Data access to this file has not changed. Nothing's been paused. My workload's still running. As more and more blocks are being moved transparently from the HDD tier to the SSD tier, the performance of my random I/O workload increases. And as you can see, it's now done. Before I even had a chance to finish talking, it's done. All the blocks that were previously on hard disk drives for this file are now on the SSD. I was doing 2,600 IOPS per second before, and now I'm doing 60,000 IOPS per second. It was a seamless transition. There was no break in this line here. This workload was always running. Now I'm going to do a little PowerShell just to show you how I would actually deploy this. All right. Now I've had a lot of feedback from people at the booth, talking to customers, MVPs, talking at TAP summits, and people really want to know, how do I use PowerShell to deploy storage spaces? Now we have UI, we have the Server Manager UI, and that supports tiering in R2. We have this UI. You can go through the UI. You can create your tiered space. But for most customers, they want an automated manner to do this. They want a way to do this in a predictable manner, a repeatable manner. So this is why I want to show the PowerShell demo here. So first thing you do with storage spaces is that you start from physical disks. So I attach my JBOD to my servers, and some disks show up. In this case, I'm actually using a VM. I'm cheating a little bit. I'm using a VM, and I'm using VHDs. You can certainly do this in a test environment, but we don't recommend you do this in a production environment. All right. So I have eight VHDs attached to this VM. Now you can see when I queried for the physical disks in the system, I can see by the can pool field, 6 of them can be pooled. All right? So I'm going to grab those 6 disks and stick them into my $disks variable. Okay, so I have my disks that I can pool. Now I create a storage pool. I simply I do new storage pool, pass in the subsystem, pass in the friendly name, and pass in the disks. Now storage spaces is going to go to all those disks and write out its metadata. And what's really cool about Spaces is that in the manner that it writes out its metadata, it actually writes it out such that each disk has a unique knowledge of every other disk. So for instance, if I was to pull one of these disks, Spaces will be able to tell me that I have a disk missing. Also, if I take one of these VHDs and put it in another VM, a completely separate VM, Spaces will tell me I have 5 disks missing, because each disk has a knowledge of every other disk in the system. All right? So now I'm going to look at the media type of these disks. This is a new field we added in R2. And basically, if it's an SSD or HDD. Now, Windows will automatically detect for Spaces certified hardware, Spaces certified disks, whether it's an SSD or HDD. So, for instance, if I'm using SSD, I'm going to get an SSD. If I'm using HDD, I'm going to get an HDD. Now, if you're not using Spaces certified hardware, we will likely have this media type as undefined. And you can set this media type when you add the disk to the pool. Or you can override this media type also if you'd like. So on my storage pool, I have these SSDs and HDDs. I'm going to go create tiers on my storage pool. I'm going to create a SSD tier, and I'm going to create an HDD tier. Now, this is another new command in R2. New storage tier, storage pool name. I give it a friendly name for the tier, and I give it a media type. All right? So I have these two objects, these two tier objects. Now it's the process of creating my tiered virtual disk. Now, I don't know how many of you are familiar with the new virtual disk command, but it's very similar. I just have two new fields, storage tiers and storage tier sizes. I simply pass in the tiers. I pass in how large I want my tier distributions to be. So in this case, I've chosen 150 gigabyte SSD tier and a 1.75 terabyte HDD tier. I want a mirrored space. And another new command for R2 is I choose a write cache size of 5 gigabytes. Now, what this command is going to do is going to go look at the SSDs in the pool. It's going to see how much capacity I have available. It's going to go take 5 gigabytes from the SSD tier for my write-back cache, and it's going to go take 150 gigabytes from the SSD tier for my SSD tier for this virtual disk. And that's going to take 1.75 terabytes. Now, the actual size of the virtual disk is determined by the storage tier sizes variable I passed in, because the write-back cache is not technically a part of that virtual disk that I would create. It's simply a staging area for this virtual disk for those small random writes. Okay, so I create my tiered virtual disk. Now I'm going to format it and throw some files on it. Give it a volume drive letter so I can easily play around with it. Okay, so I have two files that I just copied in. One is archive1 VHD, one is marketing pool VM parent. So this is our capability here to now override automatic data placement. I simply set file storage tier, pass in the files path, pass in the storage tier I want it pinned to, and I execute this command. Oops. All right. So I just pinned my VM parent to the SSD tier. I'm going to go pin my archive to the HDD tier now. So you see these commands are very simple. Now I want to get the status of where files are in the volume. You can see that my archive1, the file size on desired storage tier field is 0, which means that none of this file is on the tier that I want it to be. It's not on tier, and the state is pending. But this marketing pool VM parent, the entire file is on the tier. Now, normally, because tiering is a scheduled task and is periodic, every day, every night at 1 a.m., we'd come along and process this pin request and then move the data to the appropriate tier. Now, unless you guys want to stay here until 1 a.m., let's go force this operation immediately. So we added a new field to optimize volume. That's tier optimize. And this simply kicks off tier processing immediately. Goes in a database, figures out what I want it to do, and it moves the data transparently in the background. So I've optimized it. Now let's look at the status. Both files are completely on the tier. Tiering has looked at this database, figured out what it needs to do, and has done it. And all the PowerShell here is available on my slides in the appendix. So you can look at that before we have the official documentation in white papers and on MSDN. You can look at how I would do this. Okay, so let's jump back to my presentation here. We have a number of partners that have Spaces certified hardware. And just in the past 2 weeks, we have added 2 partners to this list. And if you were here last year at TechEd, this list was much smaller. We have partners, they recognize that customers want these types of products, and we're working very closely with more partners to deliver even more Spaces certified hardware. And you saw that Spaces Windows Server catalog.com has a list of all the certified hardware. Now these partners, Radinc, Fujitsu, DataOn, Quanta, and Supermicro, they all provide some Spaces certified hardware. They have high performance servers as well. So we would encourage you to talk to these partners to see what products they offer such that you can evaluate Spaces. And of course, we would encourage you to talk to partners that you already work with, namely the OEMs that you already work with, to determine their support for Spaces, determine what hardware is coming in the pipeline, if any. So a couple of takeaways. With tiered storage, I utilize the best characteristics of SSDs and HDDs in a single virtual disk. Windows manages your data. Windows figures out what data is hot, what data is cold, and moves them to the appropriate tier. I have hard disk drives. They're low cost, very high performance. And this stores my cold data set. I have SSDs. They're very high performance. They're higher in cost, and they're a little smaller. And these store my smaller working set. And this is all within a single virtual disk. So it's very easy to manage. Windows Server 2012 R2 gives you cost efficiency, gives you scalable data access, capacity, and performance, gives you continuous availability, and it's operationally simple. I manage it easily through PowerShell, as you saw in the previous demo, and through SCVMM. We have another number of talks on SCVMM, so I'm sure you guys can refer to those as to managing storage and managing your entire end-to-end stack. So there are a number of related sessions, and I'd definitely encourage you to look at that. There's lots of great information here, and a lot of these are available online, so you can definitely look at that. And if you have any other questions other than the ones that we're going to answer here, I'm going to be in the storage booth likely tomorrow morning, and you guys can ask me questions there if you have any other questions. You know, we have bits available now. We have the R2 preview. You can download that at the link, and I believe the materials distribution desk, if you hand them your tag, they will give you a USB key that has the bits on there. So definitely I would encourage you to go over there. You know, once you have Windows Server 2012 R2, you have Spaces hardware, you have those JBODs, you have disks, or maybe you're just setting up a test deployment with whatever stuff you have lying around. Or maybe even you're using VMs in a VHD. We definitely encourage you to try out Spaces, try out what it offers you. You know, try out tiering, see if it works for your workloads. We definitely encourage and want feedback on this preview release before we ship RTM. And we also encourage you to try out System Center as well, managing of Spaces, managing of file server, your entire end-to-end stack up to your virtualized workloads. And of course, please evaluate the session and provide feedback as need be. So I want to open the floor to questions. And of course, if you have other questions, just stop by the storage booth if you haven't thought of any here. So questions? No questions? Sorry? Oh, so the gentleman is asking, have you tried benchmarks compared to a SAN? Yeah, so we actually don't make direct comparisons with SANs. It's really workload dependent. I know some of our customers, such as Philip here, he certainly has experience with different storage products. Perhaps you can chat with him privately, but we don't make direct comparisons with SANs. However, Spaces scales to whatever hardware you used. You saw we had that 24 SSD 2U unit. We got 1.5 or close to 1.5 million IOPS out of that. 1.5 million IOPS. We actually have taken that unit, added another one to it, and taken those same 3 clustered file server nodes. So in this case, we had 48 SSDs. We're able to pump out 2.7 million IOs per second out of this storage, out of 48 SSDs with 3 file server nodes with a mirrored space. So you had resiliency, you had high availability. Spaces scales to whatever hardware you have. And with storage tiering and with write-back cache, it gets even better than 2012. Yeah. Yes?
In the presentation, there was shown only 2 tiers. It's possible to create more tiers?
So the question, you guys heard the question. So with this release, we have focused on delivering capacity, and we focused on delivering performance. So the most compelling hardware that's available today is nearline 7200 RPM drives for capacity and low cost, and high-performance SSDs for very high performance. So in this release, we have delivered 2 tiers. However, our architecture is certainly scalable to more tiers in the future for different types of data access. But in this release, we found that customers really wanted, because there was such a disparity in their workload. A lot of their workload was cold, and a lot of their workload was very hot. they had a lot more cold workload, so it really made sense to deliver at least 2 tiers in this release. And this is exactly what we focused on.
Okay, the next question. Because classical producer of the storages which are using SSD and there are possibility to hold the data, that means moving data online between the SSD and the classical drives, are trying to avoid using SSD because of burnout. By the too much moving of the data, you can destroy them. How you solve this problem?
Yeah, so we actually have a configuration that you can set how much data you want egressed from your SSD tier at any processing time to reduce the amount of data that leaves your SSD to try and reduce the amount of wear on those SSDs. However, SSD technology is continuing to improve. Many eMLC drives today, enterprise class drives today, they offer a lot of read-write cycles. They'll offer a lot of lifetime for those drives. The technology has changed so much in the past 2 years. It's just mind-boggling. Even approaching the rewrite rates of SLC with some vendors. So it's really neat products out there that are available today. But yeah, we are definitely cognizant too that SSDs can eventually wear out over time. And well, if those SSDs wear out, we have spaces that provides resiliency for those failed drives. And that works just the same for storage tiering. So if a drive fails, I can replace that drive easily. Yeah, thank you. Any other questions? Yes.
So Brian, in one of your slides, you showed that you in your internal labs had a 6 times reduction in number of server systems.
Yes.
So how does it happen? I understand that reduction in cost per IOP, but why 6 times reduction in server units? How does it happen?
Good question. So the case study is actually available online, and I don't go into the depth in this talk. But what the release team was doing before is they had a mix of traditional storage and they had a mix of servers with some storage. So they had some custom infrastructure to sort of distribute their data amongst all these different servers. The way that they were doing it, by moving it to spaces, by moving it to these 60-bay JBODs, really high density, they're able to reduce a lot of those servers with storage that they had before. And that's why we saw a 6x reduction in the number of servers they needed to manage all their data. Because they had for each server they had a limited amount of storage they can connect to that, because it was all using direct attached storage. There was nothing shared. So Spaces offered them a lot more density.
How does this storage perform on iSCSI instead, if you want to have both Hyper-V and iSCSI for something else?
Okay, sorry, can you repeat that one more time?
The iSCSI target, if you use iSCSI target together with the Windows storage spaces.
So storage spaces, the whole premise of storage spaces is to reduce cost and reduce complexity. By using simple JBODs, by using disks, by creating a pool from these disks, it's very simple. However, by creating a pool from a bunch of iSCSI LUNs, I have to manage those LUNs, which have its own intelligence behind it, be it from Windows iSCSI target or be it from a storage array. There's some intelligence behind those LUNs. I have to manage that. It's another layer of management I have to go through. Especially if I'm using a storage array LUN, be it Fibre Channel or iSCSI, maybe if one of those LUNs, one of the actual disks behind the LUNs fails, I don't get administration events coming up through the stack. It's harder to manage. There could be functionality or performance issues by having yet another layer between my virtual disk. So it's really complex, and we definitely don't recommend deploying spaces on top of iSCSI or Fibre Channel. Recommend simple SAS, the cheapest possible way to deploy your storage. Does that answer your question?
Yeah, maybe I'm just thinking wrong. I was thinking about iSCSI on top of this.
Oh, absolutely. So you can share out your storage via SMB. Yeah. You can share out your storage via NFS. Scale of File Server supports both. You can add an iSCSI target role within the cluster, so you can share it out via iSCSI. So it's very flexible as to the ways you can share out your storage.
And performance on NFS would also be good?
I'm not as familiar with NFS. If you come down to the storage booth, there might be a person more familiar with NFS. Yeah.
Thank you.
Yeah, thank you. Any more questions? All right, well, if you have any more questions, definitely stop by the storage booth, or you can send me an email. My email address is very simple, brian.matthew@microsoft.com, spelled exactly like I have in my session. So definitely fire me an email if you have any more questions or stop by the booth. Thank you so much. Have a good evening.